In you go, little beast.
As global populations expand, the search for new energy sources has increasingly led us to the oceans. And while mechanical power generation, such as undersea turbines, is a sure bet, this little box might offer the key to a greener, more animal-friendly solution.
So for over 50 years, engineers have dreamed of a solid-state, passive energy solution, meaning absolutely no moving parts whatsoever. And since we're relying on the conductive salt water of the ocean, some have argued the solution lies in an MHD generator. And apparently it's not just the engineers and inventors who think so.
You see, 2 years ago I designed an MHD thruster. By electrifying salt water in the presence of strong magnets, it produced visible thrust. A few months later, I then improved upon the idea with a circular design. This version showed real-world promise and moved a massive amount of water. It also got people in the comments wondering the same thing. What if you reverse the process? Does it generate power if you force water through it?
I mean, that's a wildly fair question, so I set out to answer that.
After weeks of 3D modeling, several magnetic field simulations, and a bit of manual labor,
oh my god,
and multiple underwater tests, the answer was a bit more shocking than I expected. This video is sponsored by Gruns, and stick around to the end because I have a $500 challenge for fellow makers. Now, how would an MHD generator function?
So salt water, electrically conductive, right? It's like a poorly conducting wire. You force that water through a strong magnetic field and it induces a voltage across the water column. Place 2 electrodes on the sides of the water column and boom, you're exporting electricity. It's really that simple. In theory.
It's Lorentz's law, but in reverse compared to MHD thrusters. I do a great breakdown of Lorentz's law in the last video, which I'll link down below, and the entire physics at play is so simple that I just hopped right into this. So I started with the basics. Using Onshape, I drafted a physics-oriented design. 3 layers of magnets, a bottom, middle, and top, separated by electrodes, creating 2 horizontal water flow chambers. Definitely not the most complicated setup, but I'll leave a link in the description down below for you to try out Onshape for yourself.
Before really building or printing anything, I reached out to my friend Chris because he has extensive experience modeling up magnetic fields, and he's actually helped with several videos in the past. So I asked him to whip up a simulation for the current design.
It turned out beautifully and indicated the magnetic field lines crossing through the water columns would be perfectly vertical, which is what I needed. That was a green light in my book, so I shot the files over to my Prusas to print out the body and the intakes of the generator. Meanwhile, I set out on a fully destructive path of discovering just how much I hate working with 316 stainless steel.
Oh my god.
It's impossible to cut, and even more impossible to sand, but stainless is needed for the electrodes to prevent corrosion in salt water.
That's good for not just the health of the generator, but also the ocean that it's sitting in. And since we're talking about health, I feel like this is a good time for me to bring up an addiction I'm honestly happy to have. And that addiction is Gruns. Inside of one of these packets are 8 delicious little gummies packed full of vitamins, probiotics, and just the right pinch of sugar. Do you remember those addictive Flintstones vitamins we had as kids? Yeah, well, Gruns, kind of the adult version. Usually generic multivitamins contain 10 vitamins or less, and at best they kind of taste like a vitamin cosplaying a candy. Gruns, on the other hand, 20 plus vitamins and minerals plus 60 whole food ingredients. It's also vegan-free, nut-free, essentially every restricted diet you can think of. Kind of a shame you're only supposed to have 1 pack per day. Because when I wake up, literally, before I have breakfast, I take one of these bad boys and snort it down because it's essentially candy without any of the guilt. Now, you might have noticed I've been growing out my hair, which these specifically help with. They contain biotin and niacinamide, which is good for finger, skin, nails. And they also contain, I think, 3 times the amount of dietary fiber as other greens gummies. So basically, they're delicious while being healthy. You can get up to 52% off by clicking this link that's in the video description or scanning the QR code also on screen. On to the generator.
Assembling the parts like a budget Avenger team, the generator came together fairly quickly with all the parts held together with a pressure fit. I designed it to be bidirectional with 2 water intakes, though that gets complicated with a fixed magnetic field.
As for what provides that magnetic field, I've got a pack full of monsters right here. And I do need monsters. This is like 20 pounds of neodymium magnets. These are N52 neodymiums. They are terrifying to work with. This is like the pressure of a small child standing on my hand. It's awesome. Seriously, I've lost so much skin to these things. For example, one of these magnets has an 85-pound pole, and the generator will have 18 of them. Now, the magnets are made of metal, so they're conductive, and they will act as a short circuit between the distance of the two electrodes. Can't have that. So, Flex Seal to the rescue. With a bit of finesse, I managed to squeeze in all 18 neodymium magnets. It's a pretty wild amount of magnets, and this thing is fairly hefty, 10, 12 pounds, but I expect it to be heavy because I built it to be quite robust. And this many neodymium magnets in this small of a space, the magnetic field on this thing is wild.
From 4 feet away, this little button magnet follows the magnetic flux directly to the generator. Its north-south faces are completely magnetically locked to the south-north faces of the generator. From 4 feet away, that's just wild. Despite the intense magnetic fields, this generator will only work with saltwater currents, so 135 grams of salt per gallon of water and an underwater pump with a diffuser will provide the flowing seawater conditions for a test. Adding the generator, and we're golden.
Right, so I've got the tank, the salt water, the pump, and the MHD generator. When it comes to measuring how much voltage the generator actually produces, which won't be that much, a simple multimeter will work perfectly for the job. So I'll connect this up and see what I get. Oh, it's already producing half of a volt. This is acting like a saltwater battery. There's an electrochemical reaction producing a half a volt at all times. That's awesome. Hopefully it adds to the voltage out with flowing water. 3, 2, 1. 200. It's dropping? It's dropping? Yeah, this design was rudimentary, but I still figured it would produce some voltage with flowing water, right? After a bit of thinking, I wondered if this generator had a directional bias built into it. This is test 2. I flipped around the generator. 3, 2, 1. What are we looking at here? It is an anti-generator. It reduces electricity. Great. That was not the problem. I did, however, identify one flaw from the test.
Despite using stainless 316, the electrodes were still corroding.
That is oxidation happening in real time. The electrodes are oxidizing as we speak. Yeah, clearly not going to cut it.
After a cup of boiled bean water, I was astonished that my brain started braining. Directional bias wasn't the issue, and neither was electrode spacing. As far as I could tell, it was magnet strength and terrible electrical isolation. Here's why magnetic field strength matters. According to the induced EMF equation, shown here, voltage is proportional to the product of these 3 variables. Double the magnetic field, electrode spacing, or water speed, and you double the voltage out. And currently, this design was leaking magnetic flux all the way out into space. If only there was a way to focus that magnetic field through only the inside of the generator.
There is. It's called a magnetic boot or clamp.
So I added that clamp to the 3D models and passed it off to Chris for another simulation.
Yeah, if you check out the field density between the 2 different models, the one with and the one without, you're kind of bleeding the flux all over the place. And when you put those C clamp in there, what you're doing is you're taking and you're rerouting that extra stuff a little bit better so that it's condensed around or in between where the C-clamp plates are. Yeah.
It's quite drastic. The first model you ran shows, a very beautiful open magnetic field that's really cool looking. And with the clamp, I see, extreme focusing of that magnetic flux where we want it. We chatted a bit more about partial versus full clamps, and I went with the latter.
Okay, magnetic field is slated for improvement. Now for the electrical isolation issue.
While the electrodes need to contact salt water in order to produce electricity, it's a double-edged sword. In theory, there needs to be total electrical isolation from the water column between the electrodes and the salt water surrounding the main body, and these electrodes are fully exposed on the outside.
I believe the generator is just sitting there and shorting through the water. Any power that's produced then just short circuits around the body on the outside. How the hell do we get around this considering it's supposed to be submerged in the ocean?
I decided a completely solid resin-printed body would do the trick. Electrodes aren't exposed to the open salt water, only to the water screaming through the water channels. The magnets are also placed outside the body as well, and a unified magnetic boot can clamp around all 4 sides of the resin body. Making this unidirectional would also simplify things. Passing this off to my Formlabs resin printer, it spat out a solid resin body that would be perfect for the rebuild, and then a quick reprint of the intake finished the job. Here's the body. You can see it's all one piece, solid plastic resin. Magnets slide into the center column and also on the top and bottom surfaces. As for the magnetic boot, I found a local welder known as Benny who was able to put up with me talking about Tesla coils for a bit, and then I polished it up at home. My measurements were a bit off, and this made for an extremely tight fit, and all I can say is that finally all that bench press came in handy. Then again, this is more of an MHD press. Topping one end of the body with an intake and then inserting the 4 removable electrodes, the rebuild was now complete.
After a bit of work, here is the second version of the generator. It's optimized for water flow, electrical isolation, and magnetic field strength, with these steel plates on all 4 sides significantly increasing the strength of that magnetic field.
Right, so this is a magnet and it's attracted to the steel plate. Other steel is also attracted to the magnet. Utterly shocking, I know. However, that steel plate is thick enough, it actually absorbs and deflects the magnetic field. So magnets on the inside equals very little wasted flux outside.
Crossing my fingers it works this time. In you go, little beast. Sitting in the water, is it still a saltwater battery? Barely. 3, 2, 1. Oh, this does not work as a generator. It does not work. The electrical isolation was drastically better than the first model, and it performed worse. I did multiple tests. The highest voltage it produced was 40 millivolts.
So I redesigned the body to extend out another inch in both directions, creating 50 millimeters of insulation between a pair of electrodes and the metal boot. Another full resin print, and back to testing version 3.
Oh dear God. It got worse. None of this made sense. Increased magnetic field strength, I increased electrical isolation, I even doubled the water flow to 4 meters per second, which is unrealistic for an open ocean. And the most voltage it produced ever was about 0.5 volt, but that was from electrochemistry just sitting there in the water. Any water flow just obliterated the voltage output. I don't know.
Look, MHD generators are experimentally used with plasma or liquid metals as the flowing medium, but I see now why MHD generators aren't used in the open ocean, why no one has filmed a video on YouTube about an MHD saltwater generator. Apart from their wildly inefficient energy output, they just face a host of problems. Oxidation, electrical isolation, constantly flowing saltwater.
So I've got a $500 challenge. Be the first to build a fully functional MHD saltwater generator, no bigger than, say, a shoebox or a basketball, capable of at least lighting up a single LED using realistic water velocities. Post a video about it and share the link in the comments. I'll hand you the cash myself, plus I'll share your video. I'll leave the challenge up for 6 months from now. Why? Because the physics says it's possible, and I want to see someone else take a stab at this. As always, I appreciate you watching, and I hope that you learned something new while watching the video. Chris, you're an absolute legend, and also my Patreons. Expect a complete rework of my Patreon page going forward. You stay classy.